Hi everyone. Happy Mr. Samulus here. Hey, I figured I'd go above and beyond the call of duty. I said duty. Um, to actually explain verbally, because that is my teaching style to show you how to do like all the steps and everything. Sorry if you don't learn that way. As people put on Twitter, don't learn from his learning or his teaching style. But anyway, excuse me. I figured I'd go above and beyond the Call of Duty. There I go again. And actually explain this worksheet step by step. Step by step. All right, here we go. So we talked about this in second hour, and I don't know if I'm going to finish this video by the time fourth hour shows up, so I'll probably continue it after that. About this section, when you see these questions, this is when the restrictions come in. So I don't know what else to tell you, but all of these that have positive ratios, what quadrant is in action? Yeah, immediately. The answer to that is quadrant 1. All right, that's the winner of the restrictions. I'm not going into them anymore. That's a previous lesson. You can watch that video of Happy Mr. Samulus going through all of those. If I made one, I may not have. Oh no, how terrible am I? All right. So anyway, where does cosine have root 2 over 2? I don't know what to tell you, man. It's 45 degrees. That's it. Or pi over 4. And as someone did actually say in the previous hour, this doesn't say radians or degrees. I don't know. I think degrees are good practice. If it's specific tomorrow, then I'll probably ask for radians on this, so be aware of that. Hey, where do you get negative 1 over 1? Wrong. Actually, it is negative 1 over positive 1. This is r, this is x, so y must be 0. That flat out is at pi. And the restrictions for cosine are either quadrant 1 or quadrant 2. I'm not doing anything else about that. You got to get them memorized. Memorization is a skill. You don't like it? Go to Twitter. All right, here we go. Y, x. Now, for those that are still struggling about chapter 2, that's your fault. You should have this memorized by now. But the side opposite, or the angle opposite 1 is 30 degrees. So this is a 30 in quadrant 1, which is pi over 6. By the way, tan's restrictions are negative pi over 2 to pi over 2. So if this was negative root 3 over 3, look at me going above and beyond the Call of Duty. Oh, it'd be negative pi over 6. That's if there's a negative there. So don't get confused. There wasn't, so that's the answer. If there was, then this is the answer. Wasn't, this is the answer. Was, this is the answer. I think you get it at this point. All right, let's move on. Oh, this is so much fun. Positive, negative, right? Right, Mr. Samulus? This is r and this is y, because it's inverse cosecant. Hey, I have a question. What's cosecant's restrictions? Same as sine. So, what's opposite negative 1 on in a 1, 2, root 3 triangle? And the answer is a 30. So this is a 30 in quadrant 4. Sorry. All right, and then again, same ratio. So we want to make this 1 over root 3. Either one's negative, but actually, because of my restrictions for cotan, hey, what's opposite root 3? It's a 60. And then what's cotangent tangents restrictions? Quadrants 1 or 2. This is a quadrant 2 answer, and it's a 60 in quadrant 2. And then this is ticking me off. It really is. Makes me want to do what I did second hour, take my ruler and start swinging it like Kylo Ren. A 60 isn't over 3. If you still don't know how to do this, it's your problem. 3 pi over 3, jump back. The answer is 2 pi over 3. So these are the things that are hicking up people left and right. We still don't know how to do these situations. All right. All right. Let's see. Our cosine of 1/2. This, if you really want to do this, actually the answer is 2. I think some people could figure that out. All right, but this is x and this is r, and then you do this, you're in quadrant 1, and then this is 1, and this is 2, and then this is some mystery theta that this gives you, and then what's the secant of theta? You go back to this triangle and do the secant, now it's r over x, which is 2. Done. Okay, this one, I love this. I even did this in the notes when we do this. This is the conundrum of the restrictions. Sine of 3 pi, you would think inverse sine of sine would cancel each other. It doesn't because of restrictions. The sine of 3 pi over 4 is a root 2 over 2. And then when you invert, what just happened? The inverse of sine, inverse sine of root 2 over 2 is a quadrant 1 answer, because that's the restrictions for when you inverse sine. What a kick in the groin, right? So the answer is actually pi over 4. Be careful. Hey! This is sine 2. When you inverse cosine this, that gives you an angle measure. All right? So actually what I'm going to do to answer this question is do the identity for sine 2 theta. And if you don't know that at this point, it's your fault. It's not bad teaching. It's memorization. All right? All right, so cosine of this angle measure is 1/3. Sine of this angle measure requires a real quick Pythagorean theorem. 3 squared minus 1 squared is 8. That's a root 2. The square root of 8. So sine is 2 root 2 over 3. Now remember, folks, 3 times 3 is not 3. Sorry for laughing at you. A lot of us made that mistake on a quiz that we had. That's not funny. I'm so unprofessional. Get me out of this class if I have to do one more day with Samulus. My head's going to explode, or I'm going to quit math. All right, when you arc sine 3/5, you get an angle. When you arc cosine 5/7, you get an angle. Lo and behold, you have the sum rule for tan, which is tan of an angle plus tan of the other angle over 1 minus tan tan. If you don't know that, that's your fault. It's not bad teaching. It's memorization. It is a skill. Okay, so how do I do the tan of theta? Am I taping? Oh, thank the maker. If there is one, remember public school, I would never say anything that, would imply a certain belief system. All right, so arc sine, this is 3, opposite side, 5. Oh, so that's 4. That's easy for this angle. This one, oh no. This is 7. This is 5 here. Oh, geez, I got to do math. I always hated math. 49, 7 squared minus 25, 5 squared, 49, 39, 29, 24. Last time I checked. Then you square root that. And then that's 4 times 6. That's 2 root 6. Okay, so now what I have to do is this. The tan of theta that comes from this triangle is 3 over 4 plus the tan of u, u, is, okay, I should really draw it. This is y and this is x. 2 root 6 over 5. That's one of my Samoses too. Tan of me, you, me. 1 minus 3/4. Trying to give everything. Make this as enjoyable as possible for all the students that all love me. All right, and then what I would do next is throw up, maybe? No, it's not that bad. Multiply both top and bottom by 20. 4 goes into 20. I'm a fraction jerk. We should know this. 4 goes into 25. 5 times 3 is 15. 5 goes into 24 times 4 times 2 is 8. Who do we appreciate? Not Mr. S. Not Mr. S. He's a jerk. And then, hey, 4 times 5 is 20. 20 to 20. Uh-oh. I got to stop this glorious video. All right, then we have to rationalize. I think I'll finish this. By the way, actually, nothing goes into all of these. Holy crap. This is a Cooper question, by the way. It's not really, though. This is actually, the kind of stuff we should do. And I hope I'm not making a mistake, because then I'm putting myself out there, make a mistake, and then it gives that student, see, he is the worst student or teacher in the world. He can't do anything right. 300... 160x this is all without a calculator, by the way. So 6 times 6 is 60, and then 30 is 90. 90 root 6, and then 6 times 8 is 48. And then root 6 times root 6 is 6. Oh gosh, I got to do 6 times 48 in my brain. I really feel like I'm making a mistake somewhere. This seems like it's going too smooth. 400 minus 6 times 6 is 36 times 6. All right, I'm going to do this without a calculator. Boy, I think this is going to be a mistake. 6 times 50 is 300, and then minus 12. 288. Boy, I'm nervous about that. Or 6 times 40 is 240, and then 6 times 8 is 48. This is all thrilling online, isn't it? 288 plus 300 is 588. Plus 250, 90 and 160. I root is 6 over, holy crap. 6 times 30 is 180. 180 plus 6 times 6, 36. 216? Oh, really nervous about that one. Well, yeah, let's give those the joy that I make a mistake and it just makes their lives 184? And then you have to find out what's in common between all three of these to divide it out. You know, I'm about to have an aneurysm. So I'm going to do this offline and then show you the final answer. I found out that all these numbers are only divisible by 2. Took me a while. So there's the first section from your melodious, happy, couldn't be happier math teacher. I'll do the rest later.